In the second part of our electric solar system series, we venture out to our second largest planet. Join us on a tour of electrical Saturn. Now, Saturn is named after the Roman god for agriculture. Its astronomical symbol represents the god's sickle. Saturn is the sixth planet from the Sun and the second largest behind Jupiter. It is a gas giant with an average radius about 9 times that of Earth's. Saturn is famous for its ring systems, which is visible from a small telescope on Earth. The rings consist mostly of ice particles with a small amount of rock debris and dust. Saturn has at least 62 moons, of which 53 are officially named. Titan is Saturn's largest moon, and it is the second largest in the solar system, and is larger than Mercury. It is the only moon to have a substantial atmosphere. It wasn't until 2019 that we were able to accurately determine the rotation speed of Saturn, and it means that a day on Saturn lasts 10 hours, 33 minutes and 38 seconds, which is very similar to Jupiter. It is the only planet in our entire solar system to have a density which is less than that of water. Saturn's interior is thought to be composed of an iron, nickel and rock core. This core is surrounded by a deep layer of metallic hydrogen, then a layer of liquid hydrogen and liquid helium, and finally a gaseous outer layer. Standard planetary models suggest that Saturn's core is similar to Jupiter's. It is believed that the core is similar in composition to Earth, albeit more dense. Saturn's interior is thought to be extremely hot at 11,700 degrees centigrade. Saturn has a pale yellow hue due to the ammonia crystals in its upper atmosphere. It is believed that the atmosphere is about 1,000 kilometers deep. The outer atmosphere is generally bland and lacking in contrast, although long-lived features can appear. Wind speeds on Saturn can reach 1,800 kilometers per hour, which is much higher than Jupiter, but still lower than Neptune. The outer atmosphere contains 93.6% molecular hydrogen and 3.25% helium. The proportions of helium is significantly deficient compared to the abundance of this element in the Sun. Similar to Jupiter, the upper clouds are composed of ammonia crystals, while the lower level clouds appear to consist of either ammonium sulfide or water. Ultraviolet light from the Sun causes methane photolysis in the upper atmosphere, leading to a series of hydrocarbon chemical reactions, with the resulting products being carried downwards. Saturn's atmosphere is banded just like Jupiter's, but its bands are much fainter and wider at the equator. In the upper cloud layers, the temperature ranges from 100 to 160 degrees Kelvin, and the clouds consist of ammonia ice. Moving lower, the temperature rises to 185 to 270 Kelvin, and the clouds are water ice. And as we plunge lower, the temperature rises above freezing to about 330 Kelvin, and the clouds are composed of water droplets with ammonia dissolved in it. Saturn does not have regular storm systems like Jupiter, but occasionally exhibits long-lived clouds and other features common on Jupiter. Every Saturnian year, a great white spot appears on Saturn, and these have previously been observed in 1876, 1903, 1933, 1960 and 1990, and it should therefore return next year in 2020. Now, the North Pole exhibits a persistent hexagonal wave pattern around the North Polar vortex. The entire structure rotates with a period of 10 hours, 39 minutes and 24 seconds, which, like Jupiter's pole storm system, is identical to the planet's radio emission period. The cause of this storm system is a hotly debated topic. Most scientists believe that it is a standing wave pattern. Thermography has shown that Saturn's southern pole has a warm polar vortex, and it is the only known example of such a phenomenon in the entire solar system. Imaging of the south polar region indicates the presence of a jet stream, but no hexagonal pattern. In 2006, Cassini observed a hurricane-like storm locked to the South Pole, which had a clearly defined eye wall, and this eye wall structure has not been observed on any other planets, other than Earth of course, when you observe hurricanes. It is believed that electrical currents in the core of Saturn are thought to give rise to the magnetic fields. Its field is weaker than Earth's, but has a magnetic moment which is 580 times that of Earth due to its larger size, and its field is about 1/20th of Jupiter. Saturn's magnetic field has a simple and symmetric shape, unlike Jupiter's complex magnetic field, and it is significantly smaller than Jupiter's. Tidal orbits with the outer parts of Saturn's magnetosphere contributes plasma from ionized particles in Titan's outer atmosphere. Saturn's magnetosphere also produces an aurora like Jupiter and Earth. In March 2007, it was found that the variation of the radio emissions from the planet didn't match Saturn's rotation rate, and this variance is thought to be caused by geyser activity on Saturn's moon Enceladus. The water vapor emitted by this becomes charged and creates a drag upon Saturn's magnetic field, slowing its rotation slightly compared to the planet's rotation. When we look at formation, and we've looked at Jupiter's formation, and we see that in Jupiter's case there are Trojan meteors, which does lend itself towards Hannes Alfvén's jet stream model. Interestingly enough, when we look at Saturn, there are no Trojan asteroids in its orbit. Now let's look at some of Saturn's satellites. Now Titan is Saturn's largest moon and comprises about 90% of the mass in the orbit around Saturn. It also contains a dense atmosphere with lakes and oceans of hydrocarbons. In 2013, scientists were able to detect polycyclic aromatic hydrocarbons in the upper atmosphere of Titan, and these are possible precursors to life. In 2014, NASA claimed to have strong evidence that nitrogen in the atmosphere of Titan came from the materials in the Oort cloud, and not from the materials that formed Saturn in earlier times. Saturn's second largest moon, Rhea, may have a very thin ring system of its own, along with a very thin atmosphere. Saturn's moon, Enceladus, is believed to have a similar composition to comets, and it is therefore believed to be a potential habitat for microbial life. Evidence for this includes salt-rich particles being ejected from the surface, which may come from evaporation of liquid salt water, not unlike our own oceans. And in 2015, Cassini flew through one of Enceladus's plumes and found most of the ingredients to sustain life in it. Now when we look at Saturn's ring system, it extends from about 6,600 kilometers all the way up to 12,000 kilometers from Saturn. And they are on average only about 20 meters thick. They are mostly composed of water, and the particle size ranged from specks of dust up to about 10 meters. Beyond the main ring, at a distance of about 12 million kilometers from the planet, is the sparse Phoebe ring, which is tilted at an angle of 27 degrees to the other rings. And like Phoebe's orbit, it is retrograde fashion, meaning it rotates in the opposite direction to the way the planet and the other satellites rotate. So let's examine some of the electrical aspects of Saturn. When they landed a probe on Titan, we actually discovered dune fields and branching canyons, very reminiscent of the Lichtenberg patterns we have seen before. Now initially they expected the surface to be covered in lakes of methane, but when they landed they only saw pebbles. Now we do see methane lakes from space. Now when Cassini approached Saturn, Saturn's magnetopores expanded by more than 1 million kilometers and then contracted and then started expanding again. And this shows that the magnetic field is dynamic. And was it responding to Cassini entering the magnetopores? Now spokes have appeared on Saturn's B rings and then disappeared, and we see huge cliffs on the edge of some of the rings. Some of these waves are as high as 4 kilometers, and we see wave patterns which move around, but still the ring remains intact. And recent findings have shown that Saturn's rings are relatively new. Christian Birkeland's experiments show various configurations when he applied charges to spheres where the plasma formed distinct rings. Is that the cause of Saturn's rings and how it maintains itself in its current shape? Why Saturn's rings are so clear compared to Jupiter's is hard to explain, but this may come down to a difference in potential. If Saturn is indeed a foreign invader, does it have a very different charge potential to the Sun, and could this explain why the rings are much stronger than on Jupiter? Again, if we go back to the idea when we looked at Jupiter, that Jupiter may in fact be a dormant star, that in fact it has many of the properties of stars, it just doesn't receive enough current. Now there is speculation that some of Saturn's storms that we see are likely caused by similar processes that cause sunspots, and by these processes I am obviously referring to, in an electric universe model, the electric processes. Now we don't just see electrical phenomena in terms of the plasma and the magnetic fields, but we also see it within the atmosphere. Now lightning strikes on the surface are about 1 million times more powerful than on Earth. And Saturn's secondary aurora is much more like Jupiter's in origin than the Earth. And on Jupiter this is caused by Io ejecting ionized material, and this forms the Io torus, and some of this material follows the magnetic field lines and ends up smashing into the surface of Jupiter. And on Saturn this secondary aurora is linked to the motion of its moons, not the solar wind. They believe that some of this plasma originates from Dione and Tethys, and each is thought to have its own torus. Cassini images show Enceladus emitting jets of plasma from the surface. When Cassini flew through these plumes, it detected charged particles coming from the surface. This is similar to Io, which too emits charged particles. As Enceladus orbits around Saturn, it must too be acting like a generator, producing vast potential difference, causing a huge current to flow back to the poles of Saturn. The Sun is too far away to explain how these jets could erupt from the surface. Mainstream believe that this is caused by the melting of ice, which then is forced out similar to geysers. The South Pole is much warmer than expected, and if you observe the cracking patterns on the surface, it seems more comparable to the forked plasma filament discharge than simple cracking of the ice surface. And there are also deep trenches which are reminiscent of features on Mars. And these are more likely formed through arcing process, which is capable of removing matter. If we examine these, we can see that there is no residue left over. And if this was simple cracking, then we would expect to see more fractured pieces of various sizes in the bottom of these. None can be seen. So it is more likely that the plumes are created by electrical discharge near the surface, and these excavate material from the surface, and these are then ionized and forced upwards as the plumes we observe. These markings are also similar to the ones found on Europa, so this too may also be experiencing a similar process, and this may also explain the volcanoes that we see on Io. We detected 90 megawatts of X-rays coming from Saturn, Now, the mainstream thought that this was because Saturn was actually reflecting the X-rays coming from the Sun. And the reason they thought that is because when you compare the image and the timeline for Saturn and the Sun, they seem to mimic each other. So when a particular pattern of X-rays appeared on the Sun, we saw the same sort of pattern appearing on Saturn, and therefore they thought that that must be reflecting. But obviously, if we go back to the notion that these two things are connected, then is it not possible that whatever drives that phenomena to happen on the Sun would equally drive a similar phenomena to happen on the other planets? Now, the question is, did we detect any similar, even not necessarily X-rays, but radio waves or ultraviolet coming from Jupiter at the same time? That would be a very interesting comparison to be. So could it be that the connection from the Sun to all of the other planets feeds that same, whether it's a jolt that causes this to happen, an extra spike in the incoming current causes it suddenly to flare up, that passes down the chain, and therefore the other planets, if they are set up, configured in such a way that they can act similar to a star, would do a similar thing to the Sun. Now, Saturn actually emits 2.3 times as much energy as it receives, and that is significantly more than Jupiter does. But by no means is it king in our solar system. When we come to talk about Neptune, Neptune is king in this field at about 2.6 times the amount of energy it receives from the Sun is what it emits. Now, the mainstream model explains this because obviously the compression model cannot explain that heating effect in Saturn's case. It is too small for that. So instead they believe that helium droplets rain down from the atmosphere into the center of the planet, and that as these droplets fall, that creates a friction, a heating effect, and that causes the extra heat to be emitted from Saturn. And this, in their case, would also explain the deficiency in helium in the atmosphere that we see on Saturn. Now, obviously, in an electrical model, just as we talked about with Jupiter, they are connected. The planets are all connected via Birkeland currents to our star, our Sun, and they are being driven, and therefore that process of the energy coming in directly or indirectly, we don't exactly know how these Birkeland currents are connected, but it creates a mini planet circuit, like we have a stellar circuit. And in the case of Saturn, it's still significantly large, so in many senses it will be acting very much like a star, and therefore the same processes that we see on the Sun are likely to be occurring on Saturn, but just with a much, much lower energy level. Now, one of the Thunderbolts' hypotheses is that our Earth was once part of a solar system which had Saturn as its star. This was then later captured by our Sun. So is there any evidence that Saturn is not related to our Sun? Now, how planets and stars form is still a hotly debated topic. But if we examine 3 of the main models, it may help us to understand what we would expect to see from the main gas giant of any solar system. Now, first up, the accretion model. We would expect to see the bodies with the largest mass having a very similar composition. Now, in Alfvén's model, where the planets form depending on the initial constituents of the gas cloud and the initial state of ionization, now, he believed that the outer planets were formed at the same time, from the same cloud, and material is distributed outwards with the majority closest to the ionization point. And the final model is where a star is fissioned into smaller bodies of possibly different sizes due to a rapid rise in the incoming current. Now, in both the fissioning and the accretion model, the constituents of the main body should be relatively similar. In Alfvén's model, this is still open for debate, as we don't really understand how evenly the material spreads, as it does this due to ionization, and then follows the magnetic field lines further out. If we examine the makeup of Saturn, we can see that it is significantly different from both Jupiter and the Sun. The Sun consists of 75% hydrogen and 15% helium, whereas Saturn is 93% hydrogen but only 3.25% helium. Now you might think that this just happens as we move further out, but if we examine Neptune, it is 80% hydrogen and 19% helium. Even Uranus has 83% hydrogen and 15% helium. So it's hard to explain how any of these models for formation could account for Saturn being so different from the other gas giants. Another oddity is the fact that Saturn has such a low density, lower than water, and no other planet in our solar system has a density below water. Now, this by itself does not prove that Saturn is an alien to our solar system, but if Saturn did form elsewhere, it is unlikely to have a composition that would be identical to the Sun, and this would be dependent on the neighborhood gas and plasma out of which it formed. To be honest, this is one of the ideas from the Thunderbolts that I find most difficult to accept. This is mainly because I think most of the evidence for this comes from interpretations of ancient records. And I personally like this to be corroborated with evidence from other sources. So this does go some way to offering credence to that notion. So what other evidence is there to support a rogue star hypothesis? Now, we have recently detected that there seems to be many stars which are being ejected from galaxies. We also know that there are several dwarf galaxies that surround the Milky Way, and this seems to be connected in a loop to our own galaxy. And the mainstream believes that this is happening because gravity is pulling this galaxy apart. But could it be a Birkeland current connecting these galaxies to our own? Either way, what is evident is that this stream of stars intersects our galactic plane. So, could this have flung a star towards the Sun? Possibly. Now, we are also starting to realize that the galactic Birkeland currents are filamented into a hierarchical structure. Now, could one of these filaments have shattered or flung stars out towards other filaments? Again, this is another long shot. And at this moment, we are only just starting to understand this structure. When we look at stars, we do not see them hopping across main flows of stars. This could well be because obviously it would take an awfully long time for this to happen, and we haven't really been observing the heavens for long enough to see this. Now, one other part of the Thunderbolts theory is that the Earth was part of Saturn's system before joining the Sun. So is there any evidence to support this? Well, water contains certain isotopes, and it is expected that as we move further out in the solar system, the ratio of these should be much higher than on Earth. Recent observations have shown that the water content in Saturn and its rings is identical to that on Earth. Even stranger is that its moon Phoebe contains isotopes which are not found anywhere else in the solar system. Now, at the moment, we don't have the same measurements for the isotopes in the water around the other planets. So this could potentially also indicate that our understanding of how these isotopes change as you move further out is incorrect. That could be another explanation for this. For now, I remain skeptical, but open to this idea. I hope you've enjoyed this look at our second largest planet in the solar system and potentially our old star. As always, be brave, be curious, the truth is waiting for us. Until next time.